Hey everyone, it's Stephanie. Now we're going to apply all we learned about position, displacement, velocity, and speed in a practice problem. Susie's driving to her friend's house at a constant velocity of 30 miles per hour. After driving for 2 hours, she lowers her speed to 50 miles an hour and continues driving for another hour. What's her total displacement? What's her average velocity for the whole trip? Okay, let's apply all this information in a problem. So Susie is driving to her friend's house at a constant velocity of 30 miles per hour. After driving for 2 hours, she lowers her speed to 15 miles an hour and continues driving for another hour. What's her total displacement? What's her average velocity for the whole trip? So the easiest way to start tackling this problem is to draw a position versus time graph. So let's draw our graph. And this is t, this is time, and this is position. And let's label the 3 points. Time. Okay, so for the first 2 hours, she drives pretty quickly. Actually, no, she's not driving that fast. So she drives for 30 miles per hour. And after driving for 2 hours, she lowers her speed to 15 miles an hour, which means the slope decreases. It's less steep. It flattens out, whatever you want to say. And she continues driving for another hour. And to find her total displacement and to find her average velocity, let's split this problem into 2 separate scenarios. So let's call the first speed of v1, and that's when she's driving 30 miles an hour. So v1 is equal to 30, and t1 is equal to 2 because she drives at 30 miles per hour for 2 hours. So velocity is equal to delta x over delta t. So 30 is equal to delta x over 2. So delta x is 60. And in our second scenario, she's driving 15 miles per hour, she's driving for 1 hour. So velocity 2 is 15, and t2 is 1. So velocity is still delta x over delta t. So 15 is equal to delta x over 1. So delta x is equal to 15. So let's find her total displacement. And since it's all in the positive direction, you just add up the 2 delta x's. So her total displacement, say delta x, total is equal to 75. And to find the average velocity for her whole trip, you just take delta x and you divide it by t. So 75 divided by t, which is 3 hours. So velocity is 25 miles per hour.